Hello, my name is Cameron Joyce. I'm a staff solutions engineer for VMware, and today we're going to be talking about VMware Cloud Disaster Recovery, or VCDR. VCDR is VMware's latest disaster recovery tool based on our acquisition of Datrium. Today we're going to be going over the components of the solution, and then we're going to look at what it would take to connect to an on-premise environment, back a workload up into the cloud, create a disaster recovery policy, and then do a test failover of that workload to ensure that everything is working as expected. So if you'll follow along with me, let's go ahead and take a look at the actual infrastructure.
Now, as we look at this architecture, the biggest thing to remember is that this is a managed service by VMware. So the center box with all the AWS components and then the right-hand box with all of the VMware Cloud on AWS components, these are built by VMware on your behalf, deployed for you and maintained for you instead of you deploying this into your own AWS environment. So if you're someone who is new to AWS and you have no deployed infrastructure, well, don't worry, we've got that for you. If you're someone who does have workloads in AWS already, we can attach your VPC to this. We can do a VPC cross connect. However, you cannot run your own workloads within the AWS VPC. Now, I want to be very clear on that because we are specifically talking about AWS native workloads and not VMware workloads. When it comes to VMware workloads, you can run whatever you'd like in the VMC portion. We're just specifically talking about AWS native services. You would need to do your own VPC and connect it into the infrastructure. Now, when we talk about how to get on-prem connected, there's always the question of, do we use a VPN? Do we need direct connect? How do we get our on-premise sending data to the cloud? And the answer to that is very simple. We deploy what we call a DRC appliance or a DR Connect appliance into every one of your on-premises vCenters. If you have a lot of resources in that vCenter, we might recommend one per HA cluster. But for most customers, they just deploy a single appliance. It's an OVA deployment. It's very, very simple, and it's also very lightweight. It's less than 100 gigs of disk to deploy that OVA. So it's a very, very simple deployment. Once we have that deployed, the OVA is what's responsible for sending your data from premise up to the cloud scale-out file system where we house all the backups. It's an encrypted tunnel, and when we land those backups in the cloud, the backups are encrypted at rest. So we don't need to worry about having any kind of in-place VPN. Everything can be sent directly over the internet and still have security that would be FIPS 140-2 certified. Okay, so now that we understand the components, let's actually get into the demonstration. Now, for this demonstration, a few of these components have already been deployed for us, and so I want to talk real quick about what you can expect in a clean environment. So when you purchase VCDR and you're setting it up for the first time, all of the AWS components will be created for you. That is part of our deployment process that happens on the back end, and that's something that support does on your behalf. So you don't necessarily need to worry about how to set all that up. It's taken care of for you. Once it's set up, you're given a URL to go to for your control shift environment. And once you log into Control Shift, we start the setup of everything else. So let's go ahead and let's go directly to Control Shift right now, and let's take a look at what first time setup looks like. Okay, so now that we've logged into Control Shift for the first time, we're going to notice that there's a few things that have already been deployed for us. The first thing that'll have been deployed for us is our VMware Cloud Scale-Out File System, or Cloud DDX. That's our backup repository. We've also deployed a VMC SDDC so that we can set up our DR plans and run our tests. And then I've got a couple protected sites here that are already built, but we'll look at how to create a new one. On the left-hand side here up at the top, I can see how to connect my different sources to Control Shift and VCDR. In this case, we're going to be doing an on-premise vSphere, and we can see the individual steps that we would need to follow to create that. So the first thing that we want to do is we want to go to the Sites tab. Now, Sites opens DVX systems by default, and we've already got one deployed. That's a support action that's taken care of for you. You don't need to worry about this at all. If you need additional STDs, or sorry, if you need additional Cloud DVX is deployed for any reason, again, support will take care of that for you. Under protected sites here, we want to go ahead and we want to click Set up for use from vSphere. We'll give the site a name. In this case, we'll call it Test 1, and we want to set it to our local time zone. Now, it's very important to set your data center to the correct time zone because when we start talking about protection groups, retention schedules, all of those great things, we want to make sure that it's correct to the time zone of that data center. You wouldn't want an East Coast data center following a West Coast retention and backup schedule. Okay, so now that we have protected site 1 here, we'll notice a few things. The first thing is, of course, our DRAS connectors. Now, these DRAS connectors are created and deployed by support, and so after you create your control shift, they will work with you to actually go ahead and deploy those. Now, you'll notice here in my on-premise vCenter that I have 4 of these deployed, but again, these are all created and set up by support. So these are not things that you need to worry about doing. It's an OVA deployment. It's very, very easy. The great thing about these as well is that they hold no configuration, they hold no data, and so these are very disposable. If we have problems with them, we just redeploy them. It's pretty simple. Once these are deployed, the next thing that I need to do is, of course, I need to connect my vCenter. So I could click Register vCenter here. I'll give it the IP or the FQDN. I'll give it my login, whether I'm using a service account or the administrator at vSphere account. As long as it's got vCenter administrator, it doesn't matter what account we use. Once we've registered our vCenter, we'll notice that the cloud backup is already automatically selected for the site because, of course, there's only one. And we can set up a throttling rule if we need to. So for instance, if I have a 100 meg pipe out to the internet, I could set a 50 meg limit so that I can ensure that I'm not going to completely swamp my internet connection with replication traffic out to VCDR. The last thing that I need to do is I need to create a protection group. Now you'll notice I have a couple already created here. We're going to create another one. I'm going to call this CTJ test. And we're going to create a VM name pattern to start with. We're going to say CTJ star. And then I want to exclude CTJ star dash star. So basically anything that includes my initials, I want to include, and then anything that's got a hyphen in it, I want to exclude. I can also add a vCenter query here, so I can do by a folder. Oops, let's do that right. I can select folders, and I can select the individual folders that I want to include VMs from. So for instance, I could say I want to grab all of the VM names that match this or anything that is in a particular folder. I can preview the VMs here so that I can see that I have all of my VMs, which is great. I do. I see them all here. This is wonderful. And then we'll go ahead and click next. So now we need to create our schedule. So this is going to be our backup schedule. So I want to do every 4 hours. I want to hold those for 1 day. Then I want to go ahead and do a daily point. I want a weekly point, and then I want a monthly point. So I want to do dailies for 2 weeks. I want to do weeklies for 4 weeks, and I want to do monthlies for 3 months. So effectively what this will give me is this will give me points every 4 hours that I will retain for 24 hours. I will roll those into a daily point. I'm going to keep those for 14 days, roll those to weekly points. Going to have one of those every 4 weeks. And then I'm going to have monthly points for 3 months. So I've got 90 days worth of retention here in this particular schedule. So we're going to go ahead and we would normally click finish. I'm going to click cancel here now that we know how to create a protection group. And then the last thing that I need to do is I need to customize my SDDC. I need to customize my software defined data center. Now, this has already been deployed, so we don't have the deploy button here. But the great thing about this is that if you're familiar with the creation of VMC on AWS, there's a lot of steps that you have to go through to deploy a new VMC SDDC, customize it, create the firewall rules, all of those things. We do all of that for you behind the scenes. All you need to do is click deploy. Okay, you don't even need to worry about choosing region because you've already done that as part of your setup with support. So you've already selected the region for control shift and your cloud scale out file system. We're going to put that SDDC in the same region, right? Makes it nice and easy. In this case, we're in US West 1. So that's, of course, Northern California. Now, once we've gone ahead and we've deployed everything here, the next thing that we can look at is my cluster size. So at the current state, I've got a single host in a single cluster, and I can go ahead and I can add hosts all the way out to 16, and then I can add additional clusters beyond 16. Additionally, if I needed to, I could deploy a new cluster so that maybe if I have applications that have some licensing requirements, I need to split those clusters up to stay within maybe my Oracle or my Microsoft SQL licensing requirements. I can build it like that. Now you'll notice that we use the i3 hosts here. i3EN is not currently selectable, but that is roadmap. And then another thing that you'll notice on host deployment here is that it jumps from 1 to 3, and then after 3, you can deploy them as you wish. Though 2 host is a supported configuration in standard VMC on AWS, we actually don't support it here, mostly because in a on-demand scenario, there's really not a good reason for a 2 host cluster. One host will do just about everything that a 2 host will do for testing. And then from a 2 host cluster, if you're using our pilot light, we don't have a way to shrink the cluster from 3 back to 2 without destroying the cluster. And so therefore you would end up having to completely redeploy everything, which is of course a huge pain. So due to some of the technical limitations, we force you into certain configurations. The other thing that you'll notice there is that you don't have the ability to configure CPU maximums for clusters. So in traditional VMC, again, for licensing requirements, you can decide how many CPUs you want all of your hosts in a cluster to actually use. We just do the default all CPUs on. Again, this is something that's non-configurable by you because we do the deployment of the SDDC on your behalf. Okay. Now, once I have my initial node created, the next thing that I need to go through and do is I need to create some networks. So again, I don't have to go through all of the traditional I don't have to go through all the traditional workload through AWS to create a network. All I need to do is add a network. We'll call it CTJDR. I'm going to use 10.1.3.1 as my gateway. I'm going to use it as /24. You'll notice LastPass there. And then, of course, I can enable DHCP if I want to. Now, in my case, everything is statically assigned. I'm not going to worry about that, so I don't need DHCP. I'm going to hit OK, and it's going to go ahead and it's going to create that network for me. So you'll notice that there I have my new network. And now I can go through and I can do things like I can request public IP addresses, right? All we need to do is we need to give it a friendly name so we know what the IP is used for, and it will create a new IP address. If we need to create some NAT rules and some firewall rules, we can do that here. So I can create a firewall rule. I can create a source, so whether that's any or a specific IP, I can define services, and then of course I can allow or deny that rule. Now, all of the default outbound rules are already created for you, so you don't have to worry about your any outbound. That's created by default. And similarly, the any deny inbound rule is created by default. So we don't need to worry about all the standard defaults. We just need to worry about additional rules. Of course, we can also create microsegmentation rules to prevent VMs or networks from talking to each other. And lastly, once I have some firewall rules created, I can also assign NAT rules to those firewall rules. So again, if I have services that need to be reachable from the internet, I can create these NAT rules here. Once I've got my customizations done, I can come up here and I can grab my vCenter credentials. You'll notice that we do actually give you Cloud Admin. So you've got full Cloud Admin, and then of course it auto-generates a password for you. I can log in here, and I can actually get my cloud-based vCenter, which is great. So again, I have full control, even though I don't have a login to the VMware VMC control panel, I still have Cloud Admin and I can still log in and do all the traditional functions that I would want to do in my VMware Cloud on AWS. So let's look back here at our protected groups next. So if I've created a new protected group, and let's look at Mike's demo group here. I've created this group. Now, this group has been created for a while, so it has some snapshots. But what if this is that new group that I just created, and I want to get my first snapshot over right away? Well, I would click my Take Snapshot group. I can create a manual name for that. So let's say VCDR Demo. And then, of course, I can select what my retention is. Do I want to keep it forever? Do I want to keep it for a day, a month, a year, hour? How long do I want to keep it? Or I can just select a specific date if that's more convenient for me. Okay. So since we have snapshots to work with, we don't need to worry about that. But again, when you're first setting this up, that initial take snapshot, that's always a good plan because again, it allows you to then start working on your DR plans more immediately instead of having to wait for that first snapshot window to hit and then the snapshots to replicate and everything to land. This can expedite that process for you. So now let's go to DR plans. And again, I've got DR plans that are pre-built here, but let's go ahead and take a look at how we would create one. So if I click on Create Plan here, I'm going to call it CTJ Plan, Demo Failover. And then I've got some options here on the plan type. Now in our case, we're going to do Failover STDC on VMware Cloud on AWS. We're going to select a protected site. So I'm going to do prod site. It's going to ask me the vCenter. Of course, there's only one. It's going to ask me which failover SDDC. Again, there's only one. And which backup cloud DVX. Again, only one. So pretty simple there. Then it's going to ask me, do I want to run tests in the SDDC or do I want to run tests not at all? Of course, we want to place tests directly in our SDDC. It's going to ask me which groups I want. So I'm going to go ahead and I'm going to grab Mike's demo. It's going to ask me failover mappings, only one. Vcenter mappings are going to be the same thing. It's going to be pretty self-explanatory. It's going to be one-to-one when this loads. And you'll notice while this loads that on the left-hand side, as I go through each step, there is a green check mark. So what that green check mark is signifying is, of course, the fact that there is a valid configuration on that stage. So as we go through this, we validate every single stage to make sure that when we finish the plan out, everything's good to go. So you'll notice that, again, I've got source vCenter, target vCenter. I need to do some folder mappings here. On my left-hand side, you're going to see in blue, these are folders that I need to map. So I'm going to map Windows over here to, of course, some Windows folders. So I'll say that'll go to applications, then apps will go to basic, and then Mike M will go to workloads. So anything that matches right on the left, we're just solidifying these on the right. If I want to select compute resources, again, I'm going to say production to cluster 1 so that, again, if I have multiple clusters in my SDDC, I can map these appropriately. My virtual networks, I have my field demo DHCP. I'm going to put that on my DR network. And then, of course, I've got my IP mapping, right? So let's go back to virtual networks real quick because it actually has one more that it needed. We're going to do that. But one thing that's great about virtual networks is that virtual networks does not require that you have NSX on premise. NSX is used in the cloud. NSXT is used in the SDDC, but it is not a requirement for on-premise. In fact, VDS, Virtual Distributed Switching, is not even a requirement for on-premise. Only the mapping is really what we require, right? Making sure that the premise network is mapped to a cloud network. That's really all we care about. And then from an IP address perspective, right, we have a few different ways that we can do this. Of course, if I add a rule here, I can look at a source IP. So maybe if my on-prem is 10.1.2.1 with a 24, I can do 10.1.3.1 with a 24, right? And then of course I can do my source subnet mask, my gateway, my source DNS, and switch these to my targets. If I have maybe a more complex rule that I want to create, so maybe 10.1.2.3 maps to 10.1.3.9 for whatever reason, I can do that. And of course, I can create my source and my destination subnet mask. So I have lots of different ways that I can create IP rules. Now, most of our customers actually don't create IP rules because they mirror their on-premise networks in the cloud. And of course, the benefit of mirroring those networks is that I don't have to worry about internal IP changes for applications that have hard-coded connectors. I don't have to worry about I don't have to worry about changing internal DNS. If I have virtual IPs, those remain static, right? So there's a lot of benefits to not doing that. But if your failover requires you to change IP addresses, of course, we can do that automatically here. You'll also notice that on all of these tabs I've had same for source and failover, and of course I can, or sorry, same for test and failover, and of course if I uncheck that, I can have a different mapping for a test run versus a true failover. And again, this goes back into creating resources for non-disruptive testing. It's a pretty easy way to do that. Now, script VM. Script VMs are a place that you can run customization scripts from. A scripts VM is a Windows or Linux VM that you run in your destination STDC. And of course, we use these as a way to run scripts without us having to worry about customizations on our end. So, for instance, if you have a bunch of PowerShell scripts and they all have a bunch of custom modules or dependencies, maybe things you've created yourself, I don't necessarily need to worry about having all those customizations in Control Shift. We just run them directly off your scripts VM machine. So it allows you for a greater level of customization when you do automation for failover, right? Versus us doing this internally. If I wanted to run scripts off a VM, I would give it a name. I'd give it the source vCenter that the name is from. And then, of course, I can use the same failover for test, or I can specify something different. The last thing is, of course, my recovery steps. So in this case, it's going to say, hey, just recover everything, which is probably not what I want to do. So the first thing that I want to do is I want to recover an individual protection group. I'm going to tell it that I want to recover the demo. And then, of course, I'm going to tell it to not power on VMs, right? That's one way I could do this. Another way that I could do it is I could tell it I want to recover an individual VM. I want to select my VM. Oops. Try this one more time. There we go. I want to select an individual VM. And in this case, right, I have a CentOS VM. I want to power this VM on. Maybe I've got some pre-recovery actions that I want to do before I recover that. In my case, I actually don't care. I just want to recover post actions, right? So I can wait for the IP address. I can wait for VMware tools. It's kind of up to you. Personally, I like waiting for the IP address. It lets me know that my customizations on the network side have worked. It lets me know that the VM is truly online. And sometimes we run into issues where maybe VMware Tools Heartbeat is not working quite the way that we want. Maybe VMware Tools itself is not installed, right? So VMware Tools is not always the best selection. In my case, I just care about the IP. And then maybe I want to run a script from the scripts VM. Maybe I want to go ahead and run a script that checks for custom services on this VM. Maybe there's a MySQL database, and I want to check to make sure that the ports are open, that it's receiving commands, that the MySQL service is running, all of those normal things, right? I can create a custom script, and I can put that here. Now, personally, I actually like doing script steps. So if I click OK here, I like doing script steps as their own step. And so the way that I can do that is I can click other actions. I can do a wait for user input. I could wait a fixed amount of time. So maybe if I know that this VM, after it comes online, it's going to take an additional few minutes. Let's say, let's wait for 2 minutes. And then once we've waited, then we're going to run our script. And the reason that I want to wait 2 minutes is maybe I just know that that's how long my services take to run. And then I can go ahead and run my script. Now, why would I want to do this as a separate step instead of as part of that recovery step? Well, the reason is that if something happens to that script, maybe it doesn't run properly, maybe I provided the wrong credentials, whatever the issue is. If I have it as a separate step, I can continuously rerun that step instead of having to continuously re-recover that VM. If it's all bundled as one, it will retry all the steps in a individual step versus retrying just the thing that failed, right? So having that script broken out as a secondary step, that's very important. Now I've got that CentOS VM. Maybe that CentOS VM had the database for my other VMs, so I can go ahead and I can recover my next group. So let's say that there's MySQL, and that's the next VM that I want to recover. I want to power it on. I want to wait for the IP. 300 seconds is fine. Now I've got that. Again, I could add another other action step. I could wait, I could script, whatever I want. And then let's say that, hey, now that the individual order of the VMs is correct, I just want to recover everything else. I could just say recover all remaining VMs, power them on, wait for the IP address, and go from there, right? So pretty simple. I've got some VMs that I want to come up in a certain order. And then once those VMs are up in their correct order, go ahead and just power on the rest of the virtual machines in that group. My last step, once I have everything done here, is of course to set up my emails. So I want to select my recipients. Of course, I can configure to add additional emails if I need to. And then, of course, I have my alert triggers. So I can tell that I want maybe every compliance check, a warning, an error. If I just want a weekly summary of everything, maybe that's a pretty good one. And then I'll do when results have changed. So when results have changed is always good because not only is it going to warn me about the errors, it's also going to warn me when things go back to normal, which is always good. I want failover execution status changed. So it's either started completed. I want user input. So if I'm waiting for something, I want to know. And then of course, failover finished and waiting for user commit. That seems pretty good here. So I can set up all my triggering and that's great. I'm going to close this and I'm going to come to our VCDR demo so that we can start taking a look at what a actual group looks like. So now that I've got this created, I'm going to go here and I'm going to check continuous compliance. Continuous compliance runs every 30 minutes, and in this case, it was run 25 minutes ago. And it looks at my protected site, my failover site, it looks at all my orchestration, and then it looks at my VMC SDDC, and it makes sure that all of the things that I have specified in this plan are available and are working the way that I expect them to work so that I can fail over. Now, this is not a 100% guarantee of a failover. This is basically just saying that are your source networks mapped to destination networks? Yes. Are certain things from the folders mapped? Yes. Is the solution within the RPO that you specified? Yes. Okay, cool. So all of those things from a high level, we can validate are still good to go. The mappings work, the SLAs work, everything's working as expected. We can talk to the VMC SDDC. We think we're good to go. This is not a guarantee, but again, it's kind of that 90% checklist because a lot of times when we test, we'll fail a test because, oh, shoot, that's right. We changed the network mapping. Oh, shoot, we changed the compute resource. Oh, shoot. Yeah, we paused that replication because something else was going on and we forgot to restart it, right? So this helps make sure that everything is available. Since everything is available, I want to test my plan. I want to test because I have an auditor who's asking me, does your stuff really work? And I say, yes, it really works. Let me prove it to you. I'm going to go under VCDR VMs. and I'm going to check which point I want to recover from. By default, it always gives you the latest. Maybe I want to go to yesterday. Maybe my auditor is saying, nope, you got to recover to yesterday. Let's say within business hours yesterday. So I'm going to select that. I'm going to hit OK. And it's going to warn me, hey, this is not the most recent, which I know. But again, it's just letting me know that, again, if I didn't intend to select that, that there might be a newer point. Then my next thing is, of course, I have the option to ignore all errors or stop on every error. I want to stop on every error because, again, this is a test. And so if there's a problem, I want to fix it. Then I have the option to migrate to the SDDC, or I'm going to leave on Cloud DVX. In this particular case, I'm going to leave on Cloud DVX. Now, what's the difference and why would I choose one over the other? Cloud DVX is really great for testing. It means that you don't need to spin up the full SDDC. You can use fewer resources. It's faster because there's no storage of vMotion involved in the testing. The downside is that the Cloud DVX has some performance limitations, right? It's backed by EBS Flash and an S3 bucket, and so it is not quite as fast as having all NVMe vSAN on the SDDC. Again, for testing purposes, this is great. For a true failover, I'd probably want to migrate it to the SDDC. That being said, if I don't choose to migrate it to the SDDC through here, I can still migrate it through a traditional vMotion, right? So I still have that opportunity later to specify that I would actually like that workload to move. Maybe the Cloud DVX is not providing enough performance and I need to move it to the vSAN. It's totally doable. I click next. It's going to give me the steps. Click next again. I'm going to click I'm going to write test plan because I want to confirm that I'm testing this. I am not failing this over. And as this actually does its test, we're going to talk about why a test is different than a failover. I'm going to click Run Test, and we'll see all of my steps here. And I'm going to go ahead and expand this out so you can see these steps. Now, what is the difference between test and failover? Well, a test is just that. It is testing that we can recover these VMs into the SDDC, power them on, do whatever it is I need to do to validate that the services are working, and then it destroys everything. It does not capture any of the actual data that changes in the SDDC. We don't do any kind of protection. We don't replicate this back down on premise. This is a non-disruptive test in the SDDC. That's really awesome for a lot of people who just want to make sure that their DR works. Maybe I have a quarterly DR test, and if I did, I could do this online during the day while I'm at work instead of having to create this after hours and on the weekend when I am not disrupting workflow, right? So those are some of the great things about test. With that being said, some organizations do have requirements to test their true failover. And what I mean by that is that their quarterly test is actually a true failover. They have to move everything to their secondary site. They have to run there for a prescribed amount of time to validate that not only did the resources come up, but that you can truly actually recover to them. If that's your organization, test is not going to work for you because test, when you clean it up with this button right here, test will just delete those resources. So all of the stuff that you've been changing and writing to and all of that in your environment will just get completely deleted. So just be aware of that. On this side, right, we saw a recovery of the VMs, we saw them register, we saw them power on. If I come to my SDDC, of course, I can see that now in cluster one, in the compute resource pool, if I look at the DRAS resource pool, I can see my workloads now, and I can see in my recent actions all of the things that happened to build these VMs. Now, let's say that I've tested everything looks good, and it's time to clean it up. All I need to do is click clean up. I'm going to click clean up test, and it's going to do exactly that. It's going to clean up the test. Now, when it cleans up the test, it's going to power off the VMs, it's going to unregister them from vCenter, and then of course it's going to delete them. That happens very quickly. You'll notice that again, under DRAS resource pool, there's nothing there anymore because we just cleaned it up. I'm going to go ahead and I'm going to acknowledge it. I'm going to say demo, oops, video, and I'm going to acknowledge. Now, why do I need to acknowledge the cleanup? Why do I need to do all this? Well, it's because we specify users to actions. So every time you do things like a test creation, a test cleanup, a failover, a failback, any changes, we associate that to users, right? So that's all part of auditing, which is very important for environments that, of course, have audit requirements to map users to actions. If I go into my reporting here, we can see the test that we just did, and I can create a PDF report of that so that I can validate that everything just worked. So again, for my boss who needs to see that I'm actually doing my job, here it is. Here's your report. It's going to give me some executive overview. So I can see that this test took me about 2 minutes. Specifically, it took me a minute and 18 seconds to execute my test. It's going to show me all my mappings. It's going to show me my high level steps. It's going to show me what it actually did. And then, of course, I've got a full action log. If there were errors, it would show up in the error log. And the same thing, if there was an issue with the cleanup, it would show there. So now I have full documentation of my test, what happened, who did it, and I can send this off. I don't need to be up any longer than I need to be. So if you are still testing in the middle of the night or on weekends, it's 4:30 in the morning and you don't want to generate that documentation, you don't have to. It's right here. I can also delineate between a true failover versus test. So if I have a lot of these in here, like for instance we do, I can always specify whether I'm looking just for failover reports or just for test reports. Under configuration changes, again, if I have any config changes, I can create reports around the config change that occurred. And so if I have a change control that requires a pre and post report of my change, I can select any of these. I can create a PDF report. I can attach that to my change control. And again, one last thing for documentation. The last thing that I want to show you is, of course, the Users tab. Now, the Users tab is a group of users that we allow access to Control Shift. These users can have custom roles. So for instance, if I just needed an auditor role for maybe a CISO or maybe a contractor like Deloitte or PwC is here, and I need them to just be able to look through my stuff but not actually change anything, I could invite them to my instance as an auditor. Of course, if I select individual things, right? So I can also select individual roles. I can give them the full administrator if that's what I want to do. I have a lot of ability here. Again, if I have maybe some junior admins that are able to execute plans and manage the backup policies, but I don't want them to do anything else, right? I can select these roles. So I can get fairly granular with how I'm giving people permissions in Control Shift to ensure that maybe a knock admin who I need to be able to fail over and test and validate backups and maybe update backups or rerun backups if that's what needs to happen, does not have access to do things like maybe change a DR plan. Um, because maybe a step failed, right? I don't want them meddling in my plans. I just want them failing them over.
Okay, so we took a look at the VMware Cloud on AWS architecture. We then took a look at creating our control shift protected site. We created a protection group to specify the VMs that we wanted backed up and how long we wanted to retain those points in the cloud. And then, of course, we also went through the process to create a disaster recovery policy and then tested that DR policy against our VMware Cloud SDDC. Now, there are a lot more things that you can do with Control Shift. There's a lot more examples. And then, of course, when we talk about on-premise workloads, when we talk about capabilities in SDDC, there's a lot that we didn't cover in this video. So if you'd like to know more about that, I'd encourage you to take a look at the links on the left-hand side here as a way to get in touch with me or any of my colleagues at VMware to learn more about the VMware Cloud Disaster Recovery Service or VMware Cloud on AWS. I want to thank you for your time today, and I look forward to seeing you soon in another video.